Hello, guys and gals. I'm running out of things to say here at the start to start a video. I don't know how to do this. Anyways, let's dive in. So just real briefly, a warm up, brief conversation, and then practice test time. So for the warm up, go ahead and pause the screen. Give these a shot. All right. Hopefully you had a chance to try those. Let's briefly go over them as usual. All right. So for the very first one, here we have some functions. State the domain of f. This just means what x values can you put into it. Remember, for logs, you cannot put negatives or zeros inside of logs. So what we want to do with this function here, we want to just we're asking ourselves what is going to break it, and we want to set it so that it doesn't break it. So I'm just going to set the inside here to be greater than 0. It can't equal 0, it needs to be greater than 0. There's a couple ways to do this, but we haven't looked at a graph in a while, and I thought it might be another interesting way to look at this. So if I just graph this function, here I see this function has a 0 at 0, or an x-intercept at 0. It also has an x-intercept at 2. So here's the curve. This is just a positive parabola. We know what those look like. And again, for natural logs, you only are allowed to put positive things in. So from looking at the graph here, I see that positive things are produced when x is less than 0. And I see that positive things are in there when x is greater than 2. So I get the domain, which is kind of a weird domain. X is greater than 2 and x is less than 0 graphically. You can also get the same result algebraically, but there it is graphically. Okay, next one, find f prime, the derivative function, the slope function, the gradient function. Remember, all those are the same thing. Find an f prime here. Well, I want to remind myself of what f was, and this form is way easier. Earlier in this other form, there's a little bit more involved. We'd end up doing product rule. We can simplify algebraically first before doing calculus to make the calculus easier. Distribute your x into both of those, and I get that x is this. Now that's quite a bit easier to do u prime over u. Remember, for natural logs, it is u prime over u. Take the derivative of the top, 2x minus 2, over the bottom, leave the bottom alone. There's your answer for that one. C, find the equation of the tangent line 2f at the point where x is equal to 3. Okay, so remember, for these ones, we need to know what is our slope at 3. The slope function evaluated at 3. You plug that in, and I think you get 4/3. And then we want to know we need the point. So if you plug 3 into the original equation, you get this. So now we have a slope, you have a point. Again, this is just some x value 3, some y value here. So now that you have a point. Now that you have a slope and a point slope form, some sort of vertical stretch. Your x is shifted by that amount, -3, and then some vertical shift there. There it is, an equation in tangent form. If you want a slope-intercept form, go and distribute it in, but it's not required, and here you go. All right, let's look at question 2. A and B are two events such that probability of A is 1/3, probability of B is that. Let's look at this. Okay. So first off, mutually exclusive. Mutually exclusive means there's no overlap. They cannot happen at the same time on the Venn diagram. They don't overlap. So there, I know the union is just adding them together. We don't have to do the subtracting out for double counting stuff. So it's just 1/3 plus 2/7. Get common denominator, and I do believe you're going to get 13/21. Okay, independent now is fundamentally different. Independent means there can be overlap. It's just they don't impact each other. Again, an example is like pulling a card out of a deck and rolling a die. They can both happen. You could get a 6 and a 6 from both events. They just don't affect each other. So those being independent, we're using this definition. The definition of independence is that the intersection is just equal to the probability of one times the probability of the other. So because I'm told they're independent, I can find the intersection by multiplying those two individual probabilities, and I get 2/21. Okay, let's look at part C here. All right, so now that we have the intersection, that's not the answer, now that we have the intersection, now we can plug into the general union equation. This is usually the union equation. The probability of A union B is equal to probability of A plus probability of B minus the overlapping that you end up double counting. So now this was given, this was given, this we just solved for, plug them all in, and I do believe you're going to get 11/21. There's your end answer. Part B, find A given B. if they tell us the union here. All right, so here, first off, the given equation. The given equation, the probability of A given B, is the intersection of those two things divided by whatever is the given, so divided by probability of B. We know the probability of B. We don't know this one yet. This is new. We don't know if they're independent. We don't know if they're mutually exclusive. We don't know the intersection, so that's what we have to solve for first. To do that, I'm going to use what they've given us on the union because over here they told us what the union is. Since they told us that union, I'm going to plug into this union equation here. Plug into that thing. Here's our union, the probability of A, the probability of B, and we're solving for our intersection. Plug in, be careful, and I do believe you're going to get the intersection is 4/21. Now that we have that, we can go in over here and plug back into this. The intersection is 4/21. Probability of B is 6/21. Simplify, and I do believe you're going to get 2/3 there. All right, let's continue forward. I'm anticipating some questions on these, so let me actually take a moment and go over some of these big ideas. For question 3, use a diagram to calculate the probabilities in each sketch, the Z distribution, and shade the region of shade in the region. So here it's asking the probability of Z being between -1 and 1. Well, that would just be this region here, so that probability is those two added together. This one between -1 and 3, that means down 1 here, and then all this plus this plus this plus this all the way up to 3, and so forth. What I really want to go over is question 4. This one probably feels weird to a lot of people early on. Okay, so some variable is distributed normally with some mean and some variance there. And Z is distributed normally also, but its mean is always 0 and standard deviation is always 1. Determine the values of A and B such that. Okay, so here there's in terms of X here, it's saying below the mean, so 1 standard deviation below the mean, and this is 2 standard deviations above the mean. So again, if we're going 1 standard deviation below the mean, what Z value does that correspond with? 1 standard deviation below the mean corresponds with a Z value of -1. So here, A is -1. This one, this is the mean plus 2 standard deviations, so 2 standard deviations above the mean. What Z value corresponds with that? Well, Z of 2 means 2 standard deviations above the mean. So here, B is 2, -1 and 2. Oh, I have the answers over here also. Okay. Here, this is saying half of a standard deviation below. So that means Z is -1/2. This one's saying X is right at the mean. So it's 0 standard deviations away. So 0 standard deviations away means Z, or this value, is 0. So being between the mean and half standard deviation below, and the mean is a Z-score of -0.5 and 0. All right, this one's going the other direction. So here it's saying a Z of between 0 and 3. So this means at the mean, up to 3 standard deviations beyond the mean. So if we're going at the mean here, the number of standard deviations above the mean is 0. So A is 0 here. And then a Z value of 3, again, means 3 standard deviations above the mean. So this should be a 3 here. 3 standard deviations above the mean. Okay, and these ones here, you should be using your calculator, using technology here. What you want to do is, let me bring the calculator over here and show you. So we're in normal PDF. Our variable, I'm going to leave as a variable, but here's the big piece that you might not catch. Our mean, because it's Z, is always 0. Our standard deviation, because it's, again, Z, is always 1. So here's our graph. Now first I need to set my window up. The window I had previously is not going to work here. For Z's, we can't have negative values. Negative values are fine for Z's. So I'm going to actually set my window here. I don't know, let's go -5 to 5. That means -5 standard deviations and +5 standard deviations. Pretty big. Let's look at this graph. Great, okay. So now to do any of these, we're just integrating the area below the curve just as we have been. So let's do this very first one together. For this very first one, I'm going to go second calc, integrate. My lower bound is -0.86. My upper bound is 0.32, 0.32. and there you get that value. I'm not going to do all these. Let's do one more. Let's do E. Let's do E together. So again, I want it to unshade, so I'm going to turn off the graph for a second. Notice it's off now. Highlight it over, hit enter again. It's back on. Regraph it just so I can have a fresh shading. So now for E, the probability of Z being greater than 1.3 standard deviations. Second calc, intersect. 1.3 is my lower bound, 1.3. And now the max of my window is 5, so I'm just going to put 5. Again, that's okay because it's way beyond this many standard deviations beyond. Okay, so that probability there you see is 0.097. If you guys have other questions, shoot me an email. We can video chat. I'm always happy to help you with any of that stuff. Okay, for the rest of this day, it was going to be practice test time and question time. Dive right in. Best of luck, and I hope to talk to you guys soon. Take care.